Okay, what is up everyone? Today's video we are going to completely one shot. We are going to one shot the chapter Electrons. This video will ensure that if the question from electron which is most likely in your board examination comes in your exam, then you will score 100% marks out of it just by watching this video in the final moment. Okay, so before we start this video, I would like to request all of you to get a copy or a pen or something that so that you can write with me. And there is a very important numerical. There is one type of numerical which is going to come almost every single time, and I'm going to tell you that how to do that as well. And so let's start the video without lending, without elongating the time period. Alright, then we are now starting it, and before we start, we need to keep basic understanding on various topics and titles, such as what do you understand by uniform electric field? Uniform electric field. First of all, we are going to electric field, then we'll jump to magnetic field. So first of all, you need to understand what is an electric field. So let's assume there are two parallel plates just like this, and they are connected to a cell just like this. The upper plate is in the higher potential, that is the positive thing, and the electrons flow from right here. So this is the negative one. And now, as we know that since the electron, the current actually flows from this way, so the force, the electromagnet, the electromotive, what is it called, EMF, the electromotive force is flowing downwards. This is the direction of E. The distance between two plates is given as D. Now that we know this much, what else we need to know is the formula for E. Let's this be the B of let the potential be V, and then what happens is the force, the what is it called, the potential difference, the drop is equal to the potential of the battery that is given by the distance of the plates. This is the formula. You need to know it. The potential difference by distance. Keep this formula in your mind throughout the session. And also the force, the force here is equal to Q times E. Q is mostly E as small electron, because we're talking about electrons in this chapter, but it can vary as well. This is the general formula. You need to remember this at any cost. And okay, now we're going inside the chapter, and inside the chapter the first thing we're going to do is the derivation, the most important derivation. This is almost a certain derivation in your examination. The derivation title is motion of electron beam inside a uniform electric field. This is the title. And what do we know about electric field? The electric field, uniform electric field, let's draw it, but I don't have much space, so I'm going to do it in the side. So yeah, it's just the same drawing as you can see right here. So you may not it's not compulsory for you to draw it, so you can just let me draw it. I'm going to draw a small one because I've already done it above, and I think everyone watching this already knows what is going on in this drawing. If not, I can also explain it. Wait a minute. Let this be at V. Let this be the distance D. And if an electron is yeah, that Alright, so this is a drawing. You can see it properly. Let me zoom it. If you cannot, look at that. That is a drawing. Here, this is the path of the electron that was projected from here with initial velocity that was u. We can let it. And if you remember grade 11 derivation for the what do you say, the projectile motion derivation, then you can memorize this derivation very easily. So let's start. First of all, we of course are going to write the language, and to write, oh yeah, it was done with the velocity, you can write that as well. Yeah, first language you can write it in your own way, or you can just follow me. So if you follow me, then you can go ahead. Let me write it down. Consider two horizontal parallel plates. Parallel plates separated by a distance d. The upper plate is at the higher potential. The potential difference applied is V. As you can see here, V is applied, and the uniform electric field, or you can just say electric field strength, electric field intensity between the plates is, we know that the formula is right here: electric field power, electric field, electric potential, everything you can call it. E will be equal to V by D. That is the formula. We let this be equation 1. Now, so let's assume the beam of electron. You cannot actually take one electron according to different theories suggesting the dual nature and whatever. Let's suppose the beam of electrons are initially projected in the field, with initial velocity of, what is the initial velocity we did told that earlier, u, right? And I'll project it in the field with the initial velocity u. The direction of projection is perpendicular to the field. I told earlier that the electric field is vertically downwards, and it is, if the electron is thrown like this is perpendicular in all the cases until right here where, yeah, you get it. So then the force experienced by the electrons is, what is the formula of force we told earlier? It is Q times E. We know that very very well, right? So F will be equal to Q times E. For a stream of electron, or just say electron, you can just keep Q equal to E, and from equation 1 the value of E is V by D. Now we remember this as equation 2. Everything fair and fine, all right. Okay, so yeah, you can also write the direction E by E, V by D towards the positive plate. And why so? It's because electrons are, the current is flowing from here to here. Everybody knows that. However, since the current is flowing in this direction, the electrons will flow in exactly opposite direction. So the force experienced by the electron, the electron will experience force in the opposite direction of the current flow, and plus there is a positive charge upwards, so electrons naturally tend to go upward. Then we can find the acceleration. Then the acceleration of electrons, remember this part, along vertical upwards, the acceleration of electrons upwards along vertical direction is, what is it? Let it be ay, since we mentioned vertical direction as y earlier. So ay will be equal to what? We don't have a direct formula, so we know that force will be equal to ma will be equal to the force, you know that. So ay will be equal to f by m. That is very clear up now. Yes, it is. Okay, then put the value of force from the equation 2 right here, ev by d. So f will be equal to ev by d, and m is right there, just like that. Let this now be equation 3. Everything fine, everything cool. There is no acceleration in the horizontal direction. We know that very well that there is no acceleration of the particle of the body in the horizontal direction. So ax will be equal to 0. Simple as that. If you remember something, then you must have remembered this thing in the projectile motion. We studied projectile motion. While the item is thrown from right here, it is thrown like this, and in this case there is an acceleration in ay, the downward acceleration, but there is no acceleration in the horizontal direction. Ax will be equal to 0. If you could remember this, that's very good. It indicates that you have not forgotten what you studied in grade 11, and that's very cool. Okay, so yeah, since ax will be equal to 0, and if we let ax is equal to 0, so if x and y are the displacements in horizontal and verticals respectively, if we do that, then by the equation of motion we can say that along horizontal, what happens is s equal to ut plus half a t square. So along horizontal, s is x equal to u is ux plus half a t squared. Here we know that ux is given, ux is u, because there is only one type of velocity. So ux is u, and ax being 0, this whole term becomes 0. So this will be equal to ut. Let this be equation 4. Similarly, along vertical, y will be equal to uyt plus 1 by 2 ayt square. Uy will be 0 in this case, so this will be 1 by 2 ayt square. This is the thing. All of us are very clear up to now. We all know what is happening, do we not? Alright, if we do, then we can now move on and put the value of y. Put the value of ay from right here, equation 3. From equation 3, we know that ay will be equal to 1 by 2 ev by dm times t squared. Now to replace t, we are taking help of equation 4. From equation 4, we can basically say that t will be equal to x by u. Can we not? We of course can. So we are putting it right now, making it y will be equal to 1 by 2 ev by dm, and t is x by u squared. So the question will ask you to prove the nature of electron to be parabolic in nature. So to prove that, you can just do 1 by 2 ev by dmu squared. This much is the constant times x squared. which is in the form of y equal to ax squared. Is it not in this form? It is. So its motion is parabolic in nature. This is the derivation. If you prove this, much, you will get complete 3 marks if this comes in your examination. Alright, if there is any confusion in this, you can simply ask me or comment down below. But now we are going to, before, what will happen to the velocity, final velocity? In this figure, as you can see, let me zoom in right now. Okay, in this figure, the electron will escape from this point. That means it will go like this. Since we can resolve this, let's take the vertical and the horizontal vectors, the resolved vectors of this thing. Let this angle be theta, just like that. Then if the initial velocity is v, then the velocity after it escapes this be v, this along the x component, this along the y component. Everything is very clear up to now, right? Then if we go back to the current scenario, we can find the final velocity of the electron. We can now find the final velocity of the electron. So for the final velocity of electron, we have, it is v, that is equal to u plus at. V is equal to u plus at, or vx. For vx, let's take for overall motion. This is the equation we're going to use, and vx will be equal to ux plus axt, and vy will be equal to uy plus ayt. These are the final velocities of the electron. So from here we simply know that ax is equal to 0, so the velocity of electron in the x will be equal in all the cases, that is just u with the initial velocity, but the vy will be a bit different, being uy equal to 0 and ay is equal to ev by dm, with t being equal to that. So we can already write ev by dmu. That is the velocity. That is the velocity of the thing. You can see uy, let me check out, wait a minute. Uy will be 0, and yeah, that is the thing. And we also have x, but x will be equal to L in the figure earlier. Look at this, x is equal to L, so you can write here L as well. EV by dmu times L. This is the final terminologies for everything. Let me revise everything for you. And EV, E equal to V by D, F equal to QE, MA equal to F, and all these very simple, very sound, very easy. Let's move on. Okay, so yeah, since these are the two velocities, now we are here. These are the two velocities. We can find the resultant velocity v as the square root of vx plus vy, both single squared. That will be equal to square root of u squared plus evl by dmu squared, just like that. And also that angle and tan theta will be equal to vy by vx. This is all you need to remember. So yeah, if you can do all this, that's very good. So there is one more expression of kinetic energy, and I believe you all can do it yourself. So I'm gonna skip the kinetic energy derivation and let's move on. Okay, let's not skip it, let's just do it as well. Let's not skip that. Kinetic energy gained inside the field. We know that K gain equal to 1 by 2 mb, the final velocity squared, minus 1 by 2 mu, the initial velocity squared. 1 by 2 m is directly common, and you can just write v squared minus u squared. We know that v is vx plus by squared, and we also know that vx plus wait a minute, this is just let me write down, this is equal to this, and this in this will cut down, so let's write down v is this, everybody knows that, we just derive it. So since v is that, we can just write u square plus evl by this is the capital V, by the way, evl by dmu squared minus u squared, so this gets cut off, and this will be 1 by 2 ebl by dmu whole square. Oh yeah, there is a m as well, m should be outside, and this will be squared, so this m will get out and m will stay downwards, so this will be equal to 1 by 2 evl by dm 1 by 2 m. Yeah, okay, no m won't stay up. Yeah, that is the relation. This is not so much important, you can just calculate it yourself, that won't be asked in your examination. So we are moving on to the short questions. The questions are, is the path of the electron beam inside the uniform always parabolic? And the question is, what would be the motion of electron beam inside uniform electric field when it is projected parallel or anti-parallel to the electric field? Straight line will happen in that case, and electron is proton. There are 3 questions given, and we are going to just verbally, or I'm going to write the cases for what will happen, but I'm not going to write the questions. So in what case does the path become parabolic? The case, the requirement for the uniform electric field to be parabolic is that it must be projected perpendicular to the field. Why should it be perpendicular? Because only while the thing is passed perpendicular, the path will be parabolic. If projected parallel or anti-parallel, look at this. These are the 2 plates, and the electric field is like this. If it is projected parallel from here, the electron is passed like this, or the electron is passed like this, then the force is going down. We all know that. So what happens generally, if while going parallel, the electron tries to move to the positive position. If we push the electron like this, it will try to go upward, so it will be a retarded motion. For parallel, a retarded motion. Do you get it? Why retarded motion for parallel? An electron always tends to try to go to the positive terminal, and since we are doing it since we are projecting it towards the negative direction, it will have a retarded motion. And to for anti-parallel case, it will be experiencing an accelerated motion, which means electron itself wants to go to the positive terminal, and we are pushing it in the anti-parallel, that means the same direction. So yeah, it will be more happier and go upwards. So that's how it works. Now the another question is, an electron and a proton be moving with same speed. Electron and a proton with same speed, v is identical, or u. the same initial velocity enters perpendicular to the field. Perpendicular to the field. Which path is more curved? That means the value of basically, what do I say? Curvature means, okay, which is more curved. So we know that the equation of the thing is given by the formula 1 by 2 EV by DMU squared, right? Wait a minute. We can just simply go deflection. We can find the formula deflection in electric field is given as, what is the deflection? The deflection is equal to the kinetic energy gained. Do you understand? The more kinetic energy will be gained, this will be equal to kinetic energy gained, because the more kinetic energy, the faster it goes, the less curvature, the more deflection will happen. So the kinetic energy will be gained. So what happens is, this will be the formula of kinetic energy: 1 by 2 m EVL by du squared. In this case, we know that field is inversely proportional to mass. Since proton has a mass of proton is greater than mass of electrons that is greater than that. This is the thing. Electron has a lesser mass, so the curvature will be higher. And okay, so that is for the deflection. Now if it says for the same kinetic energy, this is same, this is given, and this says Ke identical, the same question. It says Ke identical and perpendicular more curved, the same question, but the only change is kinetic energy for same kinetic energy. We know that the formula of kinetic energy is 1 by 2 mv squared, and b, the mass, is here. So what happens is the mass of both things remain same, and the mass basically means wait a minute, why, right? Okay, let's start off with, for the same kinetic energy, the displacement is given as, what is the formula of kinetic energy? What is the formula of kinetic energy right here? Look at this. 1 by 2, let me write this first here. 1 by 2 mv squared is the formula of kinetic energy. So can I modify the equation as 1 by 4 EV by, instead of dm, I'm writing d times ke x squared. Yeah, d times ke x squared. I know you don't get it. I know you don't get this, so I'm gonna explain it. Let's start off by breaking this down. So kinetic energy equal to 1 by 2 EV by d. This is 1 by 2 mv, 1 by 4, sorry, mv squared times x squared. This is what we know. Now this 2 goes up here, and it will be 2 by 4 EV by dmv let's assume the velocity as initial, mu is square times x squared. So this is the equation that we derived earlier. This is the same thing. This is 1 by 2. So kinetic energy, this is it. So here it is. Everything here is constant, so nothing will change. So if does not matter how much kinetic energy is changed, the curvature remains the same. So now we are moving to the motion of electric beam inside uniform magnetic field. the next very important derivation. What is it? The motion of electron beam inside a uniform magnetic field. Oh my god, that derivation alone took me 30 minutes. I need to fasten up now. Okay, so let's assume a magnetic field just like this, with magnetic field lines going inside like this, and the electron is projected from here. What happens is it goes in a circular path and exits the thing just like that. After it exits, it goes in a straight path. If you take a line right here, then this will give the radius of the circle, and this will be the velocity right here. Okay, and the force will be VV. It's BQV sine theta. So in complete drawing the figure, and this is the point O where they both meet. Electron is projected through this direction, and this is the center of the circle, apparently. My bad. Okay, so now let's write the language. Consider a beam of electrons moving with v. The electrons are moving with a velocity v from here. Let's write this v a bit light. Okay, the electrons are moving with the velocity v. Is it clear and fair, right? And it enters into a uniform magnetic field of intensity, intensity b directed inward, perpendicularly inward. The magnetic force experimented by the electron is correct. It is this, is it not? Velocity v. Consider a beam of electrons moving with velocity v are projected to a uniform intensity b perpendicular to it inward. Then force experienced the formula for Lorentz force is F equal to BQV sine theta. Since theta equal to 0 and Q equal to E, it becomes BEV. The formula becomes BEV. Let this be the equation 1. The direction of this force is perpendicular to what? To what is it? Is it perpendicular? Let's see. It is perpendicular to V. It is perpendicular to, look at this, the motion of electron, the V, and the magnetic field. So it is, the force is perpendicular. The force pulled it downward, so it is perpendicular. Look at this. It is perpendicular right here. It is perpendicular to the both, and the field are going like this, like this. The magnetic field is like this. So it becomes a 90 here as well, and a 90 here as well. So that's the force is perpendicular to both B and V. That much, right? So since the force is perpendicular to the velocity, the perpendicular to the velocity, it cannot change its magnitude. Why can it not change it? Because work done is 0. Why is work done 0? Because work done, if the angle is perpendicular, becomes 0. We know that very well. Work done is a vector quantity. So yeah, work done is 0, but can change direction. So the acceleration is not 0. And what in which case does all this happen? Hence all these happen in a circular motion. So the motion of electrons is also in circular motion. You just need to write all of these and that's it. Now we know that to move in a circular orbit, the electron requires centripetal force, which is provided here, provided by the Lorentz force or the magnetic force. Okay, yeah, so it is provided by the magnetic force. So the centripetal force mv square by r will be equal to the magnetic force BeV. The V gets cancelled off and it will be mv by r will be equal to Be. And we can now write the velocity. We need to find the time period of rotation in this case, by the way. So we separate the V and it will be Be r by m, and the velocity, the radius, wait a minute, to find the radius of the thing, you can just say velocity is equal to r omega. We know that, we learned that in circular motion, so this gets cut off, and this will be omega will be equal to Be by m, and omega is 2 pi by t or 2 pi f, so that will be 2 pi by t. This will be equal to Be by m, which will give us, if we reciprocal this will be t by 2 pi equal to m by Be. T by 2 pi will be equal to m by Be. So if that's that, then t will be equal to 2 pi m by Be. This is the time period of rotation of the thing. So electron, this is the required time period of rotation of the electron. Now about the short questions, this is the most easy derivation. So the short questions we have is the path of electron beam inside the uniform magnetic field always circular? It asks, always circular. The answer is no, it will only be circular if the electron is projected perpendicular, just like the earlier question, only if it is projected perpendicular to the magnetic field. The other question is, what would be the acceleration of electron when it is projected perpendicular, parallel and anti-parallel to the magnetic field? Just the same question. It says perpendicular, we know what happens, it will go in a circular path. In parallel, the angle will be equal to 0 degree. So the formula will be equal to BQV sine 0. Sine 0 is 0, this will be 0. So there will be no force, there will be the force will be 0, that means the acceleration will also be 0. Do you get me? So this will be 0, f equal to 0, so a equal to 0. So this will result in no straight line, no curvature or straight line. A straight line, there will be no effect of the magnetic field. It will go in a straight line if it is passed parallel into it. Also in anti-parallel, sine 180 is equal to 0, so it will be a straight line as well. Alright, now that is done, we are going to the most important type of most higher ability type of solved question, that is why magnetic field is used to deflect electron but not electric field. Let me write down the question. Why is magnetic used to deflect electrons but not electric field? Why so? The question is asking us why does that happen. So electric field, oh my god, I'm so dumb. Okay, electric field, but in what cathode ray televisions? So you can just say TV pictures tube. In the big TVs of the old centuries, why were magnetic field used to deflect the electrons instead of electric field? And that is because of the radius. We know that the radius of the circle or deflection is already higher than a parabola, and that's already done. But again, we know that the radius is inversely proportional to the magnetic field. That is, r is inversely proportional to the magnetic field. That means with lesser magnetic field we can get more radius. That means we don't need use magnets and the size can be reduced, so it will be more efficient. So the radius of deflection is higher with low magnetic power, so the size can be reduced and devices are efficient. That's all right. That's the end of short questions, and now we are going on to the numericals. The top 10 easiest numericals of grade 12 are in this chapter. So I will write the question, then we will solve some numericals, and the most probable questions are just to find the radius or the time period. Mostly the formula you're going to use is just this mv square by equal to bev, or you can just say mv by be equal to or you can say r equal to mv by be. R equal to, let me write down right here, r equal to mv by be. This is the most used formula in this chapter. So we're going to question number one, and the question number one says, what does it say? Okay, the question number one says an electron having velocity of 3.52, an electron having velocity of 3.51 into 10 to the power 6 meter per second moves at a right angle to a uniform magnetic field of intensity 0.2 teslas. Calculate the radius of its orbit. This is a very easy question. You can just use r equal to mv by be, which will be equal to m is m of an electron. We must know it. Question won't give it. M of the electron is 9.31 10 to the power minus 31 kilograms. You must know it. Oh, sorry, 9.1, my bad. You must know this value. 9.1 10 to the power minus 31 kg. Velocity is given 3.51 in 10 to the power 6, and the magnetic value is given to 0.2. Electron charge is 1.6 in 10 to the power minus 19 coulomb. This will somewhere around be equal to 1 into 10 to the power minus 4 meters. This is the value of the answer. That's it. One line numerical for 2 marks. Very, very important. Very, very important question. So after this is done, we can now go to question number 2. Question number 2 is a bit different but exactly same. So we're gonna write question number 2 here. What does it say? Protons with charge to mass ratio of, okay, let me write down. Protons, is it visible though? Yeah, it is visible. Protons with charge to mass ratio of 1 into 10 to the power 8 coulomb per kg are rotated in a circular orbit of radius r inside a magnetic field, inside a very uniform magnetic field of intensity 0.2 Tesla, so that the number of revolutions per second, what does this mean? Number of revolutions per second, this is frequency is independent of r, is independent of radius, and also calculate f and find it. So let's start the solution. I'm going to fit it in this much space. Be very careful. This is a very easy question. The question is given as charge to mass ratio Q by m is 10 to the power 8 coulomb per kg. We know that very, very well, do we not? E by m is that. We don't need anything, we just can keep this value, and b we have it itself, so we know that mv square by r equal to bev. Do we not know this? We know this. We can cut one v, so mv or we can just say r equal to mv by be, right? mv by be equal to r, but we know that r, oh my god, we need to calculate that the frequency, so we need to change this to r omega first. So mr omega by be equal to r. We can cut this, and this will be this can be written as 2 pi f, right? So m 2 pi f equal to be f frequency equal to be by 2 pi m. This is exact opposite of time period, because time period is 1 by t. If you put all the values and calculate it yourself, this will be around 3.18 revolutions per second, the value of frequency, or you can just say per second. 3.18 per second is the unit of revolutions, the frequency. That's all for numericals of this question. Now we have a few more numericals. So we are doing question number 5, the final numerical, that is from electric field. Okay. We're first completing from magnetic field. Okay. The question number 3, the magnetic field numericals. Protons are accelerated from rest through a potential difference of 2000 volt, and then enters into a uniform magnetic field of 0.2 Tesla in the direction perpendicular to the field. Calculate the radius of the orbit. So you need to first find the radius of the orbit in this question. So let's do this question, and then we're gonna do the question that is from electrons. Now we are moving to electrons after this question. So get ready for the second last question of the thing. So question number 3, what does question number 3 say to us? What does it say? Protons are accelerated from rest through protons are accelerated from rest through a potential difference of 2000 volt, and then enters into uniform magnetic field of 0.2 Tesla in the direction perpendicular to the field. In the direction perpendicular to the field. Calculate the radius of the orbit. So to do this question, what do we have to do? First of all is we know that while protons are accelerated into the potential difference, accelerated through a potential difference of 2000, the what is the potential difference, volt, and then enters. First they are accelerated, then they enter. So the kinetic energy before 1 by 2 mv square is potential difference times charge, that is qv here, which is 1 by 2. The mass of the what is it? The protons, I suppose proton. The mass of proton. What is the mass of proton? The mass of proton is given or not? It is not. If it is not given, then you need to know it. So the mass of proton. I think it's 1.67 into 10 to the power minus 27. No. 28 or 27. Let me check the. Yeah, it's 27. 27 into v square, mv into v square equal to, q is given p just means e because proton have the same charge as electron but the magnitude is different, so you just write 1.6 into 10 to the power minus 19 into 2000. So v will be equal to under root 1.6 into 10 to the power minus 19 into 2000 divided by, this will also go down, so 1 by 2 into 1.67 into 10 to the power minus 27. This will be equal to somewhere around 6.19 in 10 to the power 5 meter per second. That is the velocity of the proton. Now we can just simply use mv square. Radius is b equal to mv, r equal to mv by be, or radius will be equal to mass into velocity. Mass is 1.67 into 10 to the power minus 27 into velocity is 6.19 into 10 to the power 5 divided by b is 0.2 and ve is the charge, that is 1.6 into 10 to the power minus 19, and this will be somewhere near to 0.2, right? 0.2 into 1.6. okay, so r will be equal to 0.03 meters. This is the answer. And after we have that, now we are going to the electrons numericals. That is electron. First question is electron moving with velocity of 10 to the power 7 meter per second enters midway between. I am just going to vocabulary give the questions right here. For question number 4, let me just write solution. I'll write the given again. Let me listen the question, everyone. Electrons moving with velocity 10 to the power 7 meter per second, 10 to the power 7 meter per second, enters midway between two horizontal parallel plates in the direction parallel to the plates. It is parallel to the plates, which means theta is equal to 0 degree. Parallel to the plates, right? Okay, theta is equal to 0 degree. And 5 the plates are 5 cm long. L is equal to 5 into 10 to the power minus 2 meters. and 2 centimeter apart. The distance is 2 into 10 to the power minus 2 meters. And the potential difference of V is applied. V is applied between them. Calculate V. The beam is deflected so that it just grazed the edge of the lower plate. It just grazed the edge of the lower plate. That means it just reaches the edge of the lower plate. So okay, it is made between two horizontal parallel plates. Two horizontal parallel plates, and the thing is parallel to the like this, and the thing is parallel to the plates. Oh my god, I'm sorry, it's 90. It is parallel to the plates, not the thing. So it is, if it is parallel to the plates, it goes downwards. Okay, it went downward, okay, since it says the bottom, right, deflected, so that it just grazed the edge of lower plate right here. We need to find the potential if the beam is deflected so that it just grazed the edge of lower plate. And the question also gave us E by M, that is 1.8 into 10 to the power 11 coulomb per kg. So first of all, we already know what we have to do. There is a formula and we have all the values. So let this be U, by the way. I forget every time. So Y will be equal to 1 by 2 EV by dmu square times x squared. But x here, we don't need x because x will generally be equal to L. Am I wrong? I am not, right? So we need to find the V. Oh my god, I write V so small. Yeah, V. We need to find the V, and we don't know what is the value of Y, right? Yes, I'm going to tell you everything. First, let's get the equation of V. V will be equal to Y times what will be, bro? This is very complex. Y times 2 times dmu squared by ex squared. This is the thing. What is the value of Y? The Y first of all, if you don't know, it is the distance like this. I drew in the last figure. This is Y, this is X, and this is L. The total thing is L. So X will be equal to L. Remember that. X will be equal to L. Electron came in this way. So, and it said midway. The question said midway somewhere. So midway means the equal distance. Equal distance right here. That means Y is half of D. Are you getting the point? The question had said electrons moving with velocity enters midway between two horizontal plates. The midway between two horizontal plates. That's what the question is saying. So it will be D by 2. So you can write Y equal to D by 2 into dmu squared by ex squared. You got this. So D will be squared as well. D squared mu squared by el squared. That what happened, bro. My god, is it not crazy? It sure is, right? So now if you put all the values and write the answer, which you can obviously do, okay, then what will happen? Okay, let me calculate it myself. D is 2 into 10 to the power minus 2 squared. Mass E by m is given. This is given. E by m is given. E by m is here. So we just use our calculator, which is apparently lost. Let me search it up real quick. Oh, bro, where is the calculator? Oh my god, bro, it turns out I cannot find. Bro, where is the calculator? Okay, I found the calculator. One by 1.8 into 10 to the power 11 This will be 5.55 in 10 to the power that. So you can just write down 5.55 into 10 to the power minus 12. And u is 10 to the power 7. 10 to the power 7 squared. Whole upon L squared. L is 5 into 10 to the power minus 2 squared. So that will be somewhere around 2 into 10 to the wait 10 to the power minus 12 times 10 to the power 7 squared upon 5 into 10 to the power minus 2. What is happening, bro? Okay, so we have 4.44 volt, and that is it. That is how you do it. So now that is the end of numericals for this, and we are now moving on to the cross field, and then we go to J.J. Thomson's experiment for determining the specific charge of an electron, and then we go to the numericals of that, and after that there is the most important part, that is the Millikan's oil drop experiment, which had some numericals, and then we are over with the chapter. So now we are going to the cross field. Cross field, its name already suggests us. Cross field is the thing where there is both of the fields. There is a magnetic field as well, and there is an electric field as well. Look at this. The electron moves perpendicular like this. Look at this. The electron goes like this in a cross field, because this thing will tell it to go up, but this thing will tell it to go down. So it obeys neither of them, and this is earth end, and this is the higher potential. So yeah, this is everything regarding cross field. If you want to write the definition, then write it down. If uniform electric field and uniform magnetic field are applied together with each other in such a way that the charged particle entering normally in the region passes undeviated, so that the QE, the EE will be equal to BEV. So E will be equal to BV. So the velocity can be found out by E by B. This is the thing you do numerical, very rare numerical from this, but you can still learn this, and that's it for the cross field. Only thing you need to remember is the definition and this figure, the mind makeup you need to have. And we are ending up the cross field, and now we are moving on to the next topic, and that is J.J. Thomson's experiment to determine the specific charge of an electron. We are also going very surfacely in this one, but I will ensure that you understand everything. So let me go to it real quick. Since we are in shortage of our stock copy, we are using some stock copy from earlier, which this was of simple harmonic motion, I think, most probably. So we are ignoring this and moving on from here. Very well then. J.J. Thomson's experiment. Specific charge of an electron. All right. Okay. So the apparatus is a bit complex and it won't be asked in an examination. So remember what is happening in this experiment. To determine the specific charge of an electron, the scientist J.J. Thomson performed an experiment which is based on the principle of crossfield. He used a crossfield, simple as that. It consists of a glass. It consists of a glass. It consists of a glass discharge tube at low pressure with fluorescent screen. It encloses two electrodes, cathode C and anode A. When cathode is heated by electrons are emitted. Those electrons are accelerated towards the anode by high tension power supply. After passing through whole of anode, the narrow beam of electron is obtained, which is subjected to crossfield. If only electric field is applied, the electron beam is deflected upward and strikes the point S1, and if only magnetic field is applied, the beam is deflected downward and strikes the point S2. Now the beam of electric and magnetic field are applied perpendicular to each other such that the electron beam passes under each other, so that electron beam passes undeviated, perpendicular to each other and undeviated. So we strike the point S. In this case, that happens. So, okay, let me draw the figure first. Here's the filament. Like that, and the electrons are released here by the help of a battery, a very high tension, the high power battery. Setup like this is made for the precise for the aim of the electrons, that if they hit here they reflect back, but if they hit here they go inside. And here is a cross field, just like this. Like this. This is given with a potential of V prime, and yeah, you need to understand that this potential is called accelerating potential, and this is the higher potential for the what is it called? Wait a minute, what is it called? It is called the potential difference between two plates. The potential difference. So there are two different potentials here, like that, right? So there is a bulb. We already said vacuum is present, so it is a bulb type of thing, but there also is a screen which shows the Okay, this is the screen. So in here you can see this. There are 3 points. One point is straight here, passes perpendicular the electron, goes purely straight and reaches this point, the S. When it is turned off, this goes upward and reaches this point as 1. When the magnetic field is rather turned off, then it goes in a circular path and then goes to this S2 point. This is earthed or like that. So this is the whole figure. I am not going to write a language, so I'm going to tell you what happens. Listen to me very carefully. In this figure, okay. This is the J.J. Thomson setup for determining the specific charge, that is E by M. Specific charge is E by M of an electron. This is the fluorescent screen. Fluorescent, F-L-U-R-O-S-C-E-N-T, fluorescent screen. So what happens is, what happens because this is made up of glass. This is the glass, inside is vacuum. Here inside is vacuum and this is a glass. Inside that there is a cross field including a magnetic field and the electric field of two parallel conductors. Also, there is a aimer for electrons and there is a fluorescent and here is this produces electron and this accelerates electron. What actually happens here? Look at this very carefully. The lamp releases electrons in this area, but since there is no other charge, they will stay here in a random directions with no acceleration, with no velocity or very less velocity. But when this accelerating potential is kept right here, the positive terminal, the electrons try to rush towards the positive terminal of the electrons, resulting in they are pushed, they are accelerated. So this is very high tension. This is a high tension line. This is also called high tension battery, HTB. It is also called HTB. So it will push the electrons here and they will go to the cross field. And while the field, in this field there are 3 cases. The first case is while the magnetic field is turned off and only electric field is turned on. In that case, the electrons will go straight and then go upward, as we learned in the parabolic path. The motion will be ax squared, so it will be parabolic in nature and go upward and reach this point as 2, striking this filament fluorescent screen, and we will know that it will go here. On the second case, when there is only magnetic field while the electric field is turned off, then the electrons will go in a circular path just like we studied earlier and then hit the point S2 somehow. The distances here might not be equal because of the circle and parabola differences, but it can be visualized in this way. But when both of the fields are applied, the electron goes undeviated in a straight line like nothing had happened. The formula, or the while both of them are applied, both fields are applied, it will be the electric field will be equal to the magnetic field. That is the velocity of the electron will be given by E by B. Now when the electrons, that we know that, okay. In this case, when the electrons were accelerated, we knew that 1 by 2 mv square, the kinetic energy of the electron, would be equal to this. We learned it very earlier. The energy by which they were moving will basically be equal to the energy that this thing gave them, because electrons were not moving or very less, negligibly moving before. That is 1 by 2 m, and v is E by B equal to EV. So we are finding E by M. So we need to find E by M, that is E by M, this goes here, will be equal to E by B square 1 by 2, and the V goes down just like that. So this is the relation. This is what he found out, and that's it. That is the relation. This E is not accelerating this by d. This is this. It is v prime by d. E is equal to v prime by d. You need to know that much, and that's it. The experimental value is found out to be 1.76 into 10 to the power 11 coulomb per kg. You can remember this as well. And that ends the J.J. Thomson's experiment to determine the specific charge of the electron. So now we are going through the numericals of this concept. There is only one type of numericals, so we are doing just that, and I won't even give you the question. The only thing you do is just do E equal to BV, and then find the velocity, and then use that velocity, just that much, to find the radius of the orbit. So let's do this question at least. The question says, what does it say? Okay, the beam of electrons is under the potential (1.36 into 10 to the power 4 volts) applied between plates 4 cm apart and a magnetic field of intensity 2 into 10 to the power minus 3 Tesla is applied perpendicular to each other. If no deflection was produced, calculate the velocity of beam, the radius of orbit, for magnetic field. So all of us know what to do. First of all, we are going E equal to BV. That will give us the velocity of the beam. That will be E by B, and we have both E and B. Do we not? Yeah, potential difference and distance. So V by D. So 1.36 into 10 to the power 4 by 4 into 10 to the power minus 2 all upon B is 2 into 10 to the power minus 3. This will be somewhere around 1.7 in 10 to the power 8 meter per second. After that is found, we can just find the radius by mv by be. Mv by be, this will be m. The mass we need to know ourselves. It says electrons, so 9.1 into 10 to the power minus 31 into velocity is 1.7 into 10 to the power 8 into B is 1.2.2 into 10 to the power 3 minus 3 Tesla into charge 1.6 into 10 to the power minus 19, which will be equal to 0.48 meters. Yeah, that's all. We are done. Now we are moving to Millikan's oil drop experiment. What are we moving to? We're moving to a very important part. I'm gonna write the bold thing. Millikan's oil drop experiment. Very important. Very important this is. Okay. This smells real good, bro. Try smelling it. Smell it. Oh yes. Okay. This is a very important thing. The derivation might not be asked, but one numerical from this topic I think will never be missed in any examination of NEB. Yeah, or numerical at least. It can also ask derivation. It's not impossible, but at least one numerical is a must. And this is the last topic today, which will end the chapter electrons as well. The video is well over 1 hour, so you can watch it in like 2x or some. Okay, Millikan's oil drop experiment. Before we gang bang inside the topic, we need to understand a few things, and that is weight in terms of density. First, notes. First thing is weight of a sphere. Weight of a sphere. Is mg, we all know that. That will be equal to 4 by 3 pi r cube 0, where rho is density of sphere. Everything else is very clear, I don't have to say anything. And the other thing is upthrust. Upthrust must not be the new term for you, which is the weight of medium displaced. When there is a full bottle of apple and you put a full bottle of water and you put an apple inside the water will spill out, obviously. So that amount of water spilled out, the volume of water displaced is the upthrust, is equal to the upthrust. Is it not? It is. So it is the weight of medium displaced equal to, this is mass of medium displaced times gravitational force equal to, and medium's mass is 4 by 3 pi r cube. Let's give it sigma as another constant for this density. And that is, these are the two things you have known already. Am I correct? Yeah. Now the third thing is Stokes theorem. Just remember that Stokes theorem says viscous force says that 6 pi eta r v, all that much. The direction of this is always downward. Always downward. Every time downward. Upthrust, as its name suggests, is always upward. It is always upwards. Stokes theorem is, however, opposite to motion. It depends on the motion. It's opposite to motion. It does not determine the direction by anything else, just the motion. Okay, so now that we know this much, we need to know the objectives of this experiment. Why was this done? Objectives. First objective of this experiment is basically to prove or to verify, or just it gives an evidence. It is an evidence for the quantization of charge. Quantization of charge. Q equal to NE. And the second reason is for the determination of the smallest unit of charge. Okay, now that we know why was this done, let's know when was it done. So it was done in the 19th century. That's all I know. Okay. I don't know. Let me check in the Google or somewhere. Oh my god, bro, I don't have my laptop. Let me get my laptop out. Let me check real quick. When was Stokes theorem? Oh my god, bro, When was Millikan's oil drop experiment performed? This is very not significant. What are we doing? Oh my god, bro. Okay, look at this. The Millikan's oil drop experiment was done in 1909, and the results were published in 1907. Okay, very well done. Let me put the laptop back in. Okay, now we are going to do it. Right now, we are going to derive it. Okay, so to derive it, there are two cases. First is the effect of gravity only. Second is the effect of electric field and gravity combined. So, okay. Firstly, it's gonna be under the effect of gravity only. Only the effect of gravity. Okay. Let's draw a figure first. Okay. Here is an atomizer. A wall. There is a box like this. You can see very clearly. Like this, there is a box, and there is two parallel plates with the bottom thing earthened, and this one's earthened as well. There is a sprinkler that goes to an atomizer. Say this is an atomizer, and this is the window 2. This is a window. X-rays are given through this window, and this is the window 1. Light is passed through it. The oil drops are sent in very high pressure to the atomizer, and okay, let's put the oil container as well. This is the oil container. This is the atomizer, and this is called a chamber, double wall chamber. From the hole H, there is a microscope kept here. Let this be a microscope from which someone is watching. Someone is watching here the thing, the how they move, how they fall, all that. And this is pretty much all the setup that he did. Let this microscope be M, and the observer is O. This is an oil vessel. Just say oil. Okay, so to write this is very important derivation as well. So I'm gonna write every single language as well. So hope you get everything is up to here. Now we're gonna write the main language portion. It consists of two horizontal conducting plates. Two horizontal conducting plates, just like this and this one. It conducting plates separated by a certain distance, separated by a certain distance in which upper plate. This can also be changed, by the way, but we are taking it for the general case. And upper potential at higher potential, upper plate is at higher potential. It also has through which sprinkled electrons. I got the wrong thing. The oil drops oil drops are sprinkled in. All right. They are sprinkled in by an atomizer. Everything is enclosed in double wall chamber, ensuring window 1 and window 2 are open. Okay, after this much, the next step is to tell what happens when the oil drops are sprayed. So when the oil drops are sprayed in the space between two plates with the help of atomizer, when the oil drops are sprayed, they are charged due to friction, and they are charged negatively. If they don't, by chance, if they don't get charged, X-rays do the job. X-rays do the job if they don't get charged in those, and the motion is absorbed by the help of a microscope. Okay, now the first case, the under of effect of gravity only, we turn off the electrical circuit. When oil drop is falling under the effect of gravity alone, its velocity goes on increasing. So the viscous opposing it also increases. Why is it so? Because viscous force is directly proportional to the velocity. Increases at certain stage. At a point, the viscous force balances the gravitational force. Force or the resultant weight, you can say the same thing. So then it moves with uniform velocity v1. This v1 is called terminal velocity. So what is terminal velocity? Terminal velocity is the velocity of particle after the full effect of the upthrust. That means the velocity by which the substance object moves in a medium after all the opposing force, the weight is acceleration is zero. The forces are balanced by upthrust. You can draw what is called free body diagram like this. Mg will always be downwards, there is no changes. Upthrust will always be upwards, there is no changes, and the viscous force will also be upward since motion is downward. So the 6 pi eta r v will be upward, and the velocity, the terminal velocity, is going downward again. So the v1 will go downward. We have to now derive the relation for the radius of the oil drop. And also we have to determine the Yeah, that much. We have determined that much, and we have determined the charge in the next step. So first we need to determine the radius of the oil drop. For that, we know that at terminal velocity, the net force will be equal to 0. That means the forces acting, these two forces, this and this, must be equal. There is no duvida, there is no problem in this. This force and this force must be equal. So if they are equal, u plus 6 pi eta r v equal to mg, but in v it will be v1 because in the condition of terminal velocity, or 6 pi eta r v1 will be equal to mg minus u. Mg minus u. We can take this equation 1. Trust me, I will tell this later why. Now we know that the values of both mg and u, so we just put 4 by 3 pi r cube rho g minus 4 by 3 pi r cube sigma g. I told this earlier. Why are we doing this? I already did. So 6 pi r v1 will be equal to 4 by 3 pi r cube g rho minus sigma. Now we find out the value of r. We just basically cut whatever gets cut, and r will be equal to 4 by 3 pi r cube g rho minus sigma by everything comes down, that is 6 pi eta r not 6 pi eta v1. This goes up but still stays down, so it will be 6 3s are 18, 4 by 18 is 9, 2 by 9, so 2 by 9 pi gets cut off, and I think that's all that's gonna change. 2 by 9 r cube g rho minus sigma upon n into v1. This is the expression of radius. Okay, I messed up something. Yeah. I'm just a bit too jumbo. I'm just too dumb, maybe, I think. I don't know. This also gets cut off. This thing gets cut, so it remains squared. 1 will be equal to that. Or to find out r squared, we need to now go 9 eta b1 by 2g rho minus sigma. And r will be equal to 9 yo b1 by 2g sigma minus rho. This is the equation for the radius of the oil drop. This is the radius. This is the radius of oil drop. Now we are going to equation number second method. Under the effect of gravity and electric field, you can take any sort of electric field, but the most general case is the like this. The electric field is from positive terminal at higher and at negative at low. You can do anything, it's your choice. So we are assuming that the mass is downwards, the upthrust is upward. This is always thing. This is an always thing. Do not forget it. But since that happens, if this is the case, the force, the electric force, the what is it called, the electric field intensity, the force to this electron, the QE will go upwards because the motion will be upwards. It will pull it upwards. So the force is upward for electrons, for negatively charged particles especially, because this oil drop is a negatively charged particle. We told it earlier as well. And if it is moving upward, it is very okay. Now let's assume that the QE is more powerful than mg, so it moves upward. Then since it moves upward, the the viscous force must be downwards. 6 eta pi r v must be downwards, and the velocity will be upwards. So we already know the velocity v2. Let this be. Then let v2 be the new terminal velocity. If so, at terminal velocity, what would happen? F net will be equal to 0. F net equal to 0. That is, Q plus QE will be equal to mg plus 6 pi eta r v2. So why did we do this equation 1? We know it now, right? Give this mg the other side. QE minus 6 pi eta r v2 equal to mg minus u, and this is basically this. How short and sweet has that become? How short and sweet has that now become? Look at this. QE equal to this is this. Look at this, v1. So it will be 6 pi eta r v1 plus 6 pi eta r v2. Take all the shit common, then QE will be equal to 6 pi eta r v1 plus v2, or Q will be equal to 6 pi eta r v1 plus v2 upon E, right? And we again know, we have already known the radius, so we can, this can also be written, but we need to put the radius. So this will be equal to 6 pi eta v1 plus v2 upon E, and radius is the under root of 9 eta v1 by rho minus sigma 2g. This is the equation for the charge, and with that the derivation ends. You find both the charge and the radius of the oil drop. Now the only thing left is the radius, the numericals. So the numericals are pretty much easiest ones, but once you understand, you must understand to solve the numericals like a champion. So we are solving 3 numericals, and we are going to become a champion to it. So yeah, let's start it. Okay, there is a slight change in our plan. We are actually not doing the numericals of the 3 numericals. We are doing 2 of them. One will be easy and one will be complex, and with that our one shot will end. Okay, so the easy one, the easy question is given as, let's write down the first question. Okay, it can be written down as, in Millikan type apparatus, in Millikan's type, is this visible? Yeah, in Millikan's type apparatus, the horizontal plates are 1.5 centimeter apart, with the electric switched off. The drop is observed to fall with the steady velocity of 2.5 in 10 to the power minus 4 meter per second. When the field is switched on, the drop just remains stationary if the potential difference between the plates is 2000 volt. Oh no, it's 1500 volts. 1500 volts. Calculate. There is only two things it will tell us to calculate. First thing is radius of oil drop. Second thing is how many electrons does it carry. So how can we do this question? This question is a very interesting question that can be asked in our examination as well. To answer the question, in any question you need to first read the question. So first write the given, that is the distance is 1.5. Write everything in meter while you write it first. Electric field switched off, the drop is observed to fall with a steady velocity. The velocity with the electric field switched off, the drop is observed to fall with the steady velocity of 2.5 into 10 to the power minus 4 meters. This is given 2.5 into 10 to the power minus 4 meter per seconds. However, when the electric field is switched on, the drop just remains, what does it say? The drop just remains stationary. So there is no motion if the electric field is switched on. This one is given the terminal velocity. This is the terminal velocity in the first case, and when the drop okay, first let's imagine the situation. Let's give the case 1. The case 1, there is no electric field, so there is upthrust and there is 6 pi eta r v1. Correct? Correct. So since the body is already in the steady velocity, that means it is already going through steady motion, and the question does not talk about the medium for the upthrust, so we are ignoring upthrust right now. That means mg will directly be equal to 6 pi eta r v1. Now we know the values and we just need to find the value of r, so r will be equal to mg by 6 pi eta r 6 pi eta r v. Let me change this first. Okay, we need to change the mg first. Wait a minute. 4 by 3 pi r cube g is equal to 6 pi eta r v1. Now is the density of the oil drop given. Is the density of oil drop given in the question? Oh yeah, the question has said the density is 900 as well. Density is given 900 kg meter kg per meter cube. That's given, by the way. Okay, and also eta is given. My sorry. Eta is also given 1.8 in 10 to the power minus 5 Newton per meter, Newton second per meter square. So with that you can just find the value of r as under root 6, that is 9 by 2, 2 by 9, yeah, 9 by 2. Pi will be cut off, so eta v1 by 2g rho. That will be, if you put all the values, the answer will come around 1.5 into 10 to the power minus 6 meters. For the case 2 now. For the case 2, there is an electric field now. There is an electric field and the potential difference is 1500 volts. 1500 volts. The distance between the plates are 1.5 into 10 to the power minus 2. So you already need to know what do you do now. You need to find the E, that is B by D. So 1500 divided by 1.5 into 10 to the power minus 2 will be equal to 1 that much volt per meter. That much volt per meter, the intensity. Since we now have that, we can basically find the value of the other things. So so we can now say that the electrons are moving upwards. We can assume okay, it remains constant, my bad. And g will, there is no upthrust here because the thing is constant, and there is QE. So basically QE will be equal to mg. That means we have q is q, we know that q is q. Yep, we know that, right? But from the principle of quantization of energy, let's just write pq for now. It will be mg by e, which will be 4 by 3 pi r cube rho g by e, and this will be somewhere around yeah. And now, yeah, we can now do, if you do this, after you do this, you need to do another step, that is q will be equal to ne. It does not matter what type of charge it is, q will always be a multiple of e. That's what the quantization of energy said. So ne will be equal to 4 by 3 pi r cube rho g by e. So n will be equal to 4 by 3 pi r cube rho g by n e e. This will be equal to 7.95 electrons. That will be equal to 8 electrons. And that is your answer. So yeah, you can solve that question very easily. This is very easy type of question. You can just remember the formula. I personally suggest you can basically remember the formula, this formula. What is it? The radius formula. You can simply put this formula, but you might make mistakes. So if you do this way, it is more fun to do, and it is very less likely for your question to be a mistake. Otherwise, you can just simply remember the formula and do it. So yeah, that's the thing. And now this was the easiest type of question you could find. Now we're moving on to the most difficult part of this thing, which is also really easy, which is really easy. The question is very long, so I need some time to copy it, definitely. So let me write it down right here, or in the next page. I write down right here. Question number 2. An oil drop of mass. An oil drop of mass. An oil drop of mass 3.25 into 10 to the power minus 15 kg falls vertically with uniform velocity. Falls vertically with uniform velocity through the air between two vertical parallel plates. Through the air between two vertical parallel plates. Two vertical parallel plates 2 cm apart, 2 centimeters apart, and a potential difference of and a potential difference of 1000 volt is applied across the plates. The drop and applied across the plates, the drop 45 degrees to the vertical. Calculate the charge on the wall job. Alright, then you can see this is kind of a complex question if you ask for grade 12, so it won't ask most probably in your it it has the highest possibility of not being asked in your examination, but this is a great thing for the concept of free body diagram and might help you in an entrance examination. So you must draw a diagram for this one. There is no way you can understand this without a diagram. So an oil drop of mass this much falls vertically with uniform velocity through air between two vertical parallel plates 2 centimeter apart. Let this be the positive plate and let this be the negative plate part, and the potential difference of 1000 volts is applied across the plate. The drop moves towards the positive plate being inclined 45 degrees to the vertical. What does it say? It falls downward. It falls vertically it falls downward vertically. Also it moves towards the angle by 45 degrees, so its motion will be somewhat around like this. The velocity is in this direction by going 45 degrees with the vertical. This is what he's saying. Oh my god, everything in given the question is this much. Now what are we going to do? Don't panic out. It's very easy. It is moving in this direction. That means the viscous force that opposes the motion will always be in its opposite direction. So 6 pi eta r v will be in this direction. Upthrust is not mentioned and neither is the anything given, so we are ignoring upthrust again, and upthrust for air is also very less. So we need to resolve this now. The velocity angle is 45, so this component here will be v cos 45 degrees. We all know that very well, and this component here will be v sin 45 degrees. Are we all clear with this? Yes, we are, right? If this can have components, why not this? This can also, yes, have components, and will have components like this and like this. This will pull the object upward. The 6 pi eta, this angle is vertically opposite to which angle? This angle. Very obvious, is it not obvious? Vertically opposite angles. So this angle will be equal to this angle, and we'll pull this will be 45 degree, and 6 pi eta r v cos 45, and this will be 6 pi eta r v sin 45. Now that we have resolved this much, we have done this much, you can see the figure very well, and the question is solved now. We don't have to do anything. We just need to find the charge, right? So the charge here, okay, look at this. The question is very already solved. I'm again saying it. The charge, we need to find the charge on it. So along the horizontal, look at this, the force that was responsible for the motion, or the force that pulled the electron from here to here, some force pulled it here. That's the force. That's the QE along the vertical, along the horizontal QE will be equal to what? QE is directly pulling this, but the thing that is pulling it away is this force. This force is pulling it away. So there will be 6 pi eta r v sin 45 degrees. We can let this be equation 1, and along the vertical, mg will be equal to mg is always this. Mg will be always this. You can also write here mg, also write here qe. Mg will always be this. So since mg is this, this is the opposing force is 6 pi eta rv cos 45. Now if you solve, you look at both of them, the sine 45 will always be equal to cos 45. So QE is basically equal to MV. The question is a scam, but we have to do this because to get marks, you must draw this diagram in the examination. So from these two equations, we got QE equal to mg, since sine 45 and cos 45 are the same thing. So we can just find Q by mg by E, and that will be, the mass is given, gravitation we already know, E is given as well. Where is E? So let's just do 3.25 into 10 to the power minus 13 into 10 divided by E is 1000. This will give you the value 6.5 into 10 to the power minus 19, and E is not 1000, by the way. There is distance as well. I just saw the distance. Where is it? 2 centimeters. So it will be 100 by 2 centimeters, 1000 divided by 2 into 10 to the power minus 2. Yeah, that's how we do it. The numerical is over, the hard one. It is shorter, but it is harder just that much. And now the final result, the final part of this thing, of this chapter, we are going to the short questions. And there is just 2 short questions that I'm going to tell you. Everything else is already covered. The 2 short questions I want to tell you are, can we use water instead of oil? The answer we'll write down. And what is the use of X-ray? Right here we have used X-ray. If you have forgotten already, we have used X-rays from here. Right here, look at this. What is the use of this X-rays? We need to know about that. So the use of X-ray and this. Okay, so first of all, can we use water instead of oil? The answer is no. Water has high vapor density, has high vapor pressure, so it will evaporate due to the frictional force while being sprayed. You can just write that much. While you spray the water from this atomizer, the friction here will literally burn the water. That means the water will evaporate and only the gases will come out here, or nothing might even come out. So it will evaporate. The use of X-ray is to ionize the air molecules between the oil drops. If the drops don't get enough charge. And that's the end. We have successfully completed the one short video for the chapter Electrons. The next video will most likely be the one shot for the chapter Photons. So stay tuned.